When wiring an animal hospital, especially with specialized equipment like an MRI and multiple exam rooms, it's crucial to adhere to the National Electrical Code, or NEC, and any relevant local codes. While the NEC doesn't have a specific article dedicated solely to animal hospitals, several articles provide valuable guidance for healthcare facilities and similar occupancies. Let's consider the key NEC articles and other relevant guidelines. Firstly, NEC Article 517 addresses healthcare facilities. This article contains requirements for electrical wiring and equipment in areas of hospitals, nursing homes, clinics, and similar buildings. While an animal hospital differs from a human hospital, the principles of patient safety and reliable power are similar, so many of the requirements can be applied. Secondly, NEC Article 518 covers places of assembly. This is relevant for the exam rooms within the animal hospital, as they would be considered areas where people congregate. Article 518 contains requirements for wiring, lighting, and receptacle spacing in these areas. For conduit and MC wiring, NEC Article 300.11 is very important. This article addresses securing and supporting wiring methods. It outlines the requirements for how conduit and MC cable must be fastened to the building structure to ensure it remains secure and doesn't create a hazard. Then, NEC Article 330.22 provides specific requirements for using metal-clad cable. This article covers allowable uses, installation methods, and bending radius requirements. Metal-clad cable, or MC cable, is a common wiring method, but must be installed correctly. When it comes to the MRI installation, the NEC does not directly address the specific installation requirements of an MRI machine. However, it's crucial to follow industry best practices and guidelines to ensure safe and reliable operation. The American Association of Physicists in Medicine, or APIM, Report 203 titled Magnetic Resonance Imaging Safety Guidelines for the Safe Installation and Use of MRI Systems provides specific guidance on the safe installation and operation of MRI systems. This report covers topics such as magnetic field safety zones, quench systems, and emergency shutdown procedures. Also, the National Council on Radiation Protection and Measurements, or NCRP, Report 144, titled Radiation Protection for Patients, Staff, and Visitors Associated with the Operation of Magnetic Resonance Imaging Equipment, addresses radiation safety concerns related to MRI operation. This report provides recommendations for protecting patients, staff, and visitors from potential radiation hazards. For the exam rooms, NEC Article 518.4 covers lighting requirements for places of assembly. It specifies minimum illumination levels and emergency lighting requirements to ensure adequate visibility in the event of a power outage. Next, NEC Article 518.5 addresses receptacle requirements for places of assembly. It specifies the number and location of receptacles required to provide convenient access to power for equipment and appliances. NEC Article 518.6 covers emergency systems. This article requires that places of assembly have emergency lighting and power systems to ensure the safety of occupants in the event of a power outage. These systems must be designed to provide power to essential equipment and lighting for a specified duration. Here are some additional considerations. NEC Article 90.3 addresses the use of the code. This section clarifies that the NEC is not intended as a design specification or an instruction manual for untrained persons. It's intended for use by qualified electrical professionals who are familiar with electrical theory and safe work practices. NEC Article 110 covers the general requirements for electrical installations. It includes requirements for workmanship, equipment listing and labeling, and access to electrical equipment. NEC Article 250 addresses grounding and bonding requirements. Proper grounding and bonding are essential for electrical safety, as they provide a path for fault current to flow back to the source, tripping a circuit breaker or fuse and preventing electrical shock hazards. It's critical to remember local codes and regulations. In addition to the NEC, local building codes and regulations may have additional requirements for electrical installations in healthcare facilities. It is essential to familiarize yourself with these requirements before beginning any electrical work. Examples of these may include requirements for isolation power systems, redundant power sources, or specific wiring methods. Given the complexity of electrical installations in healthcare facilities, it is strongly recommended to consult with a qualified electrician who is experienced in healthcare facility electrical systems. They can provide guidance on the specific requirements and help ensure that the installation is done safely and in accordance with all applicable codes and regulations. They can also help with the design and layout of the electrical system to ensure that it meets the needs of the animal hospital and its equipment. Here's a more detailed look at some of the key areas. Let's look at Article 517. It categorizes different areas within a healthcare facility based on the level of patient risk associated with electrical system failure. These categories include general care areas, critical care areas, and wet locations. Each category has specific requirements for wiring methods, grounding, and the type of equipment that can be used. For example, critical care areas require redundant power sources and special grounding systems to ensure patient safety. General care areas have less stringent requirements, but still require compliance with all applicable NEC standards. Next, consider the exam rooms and how they are handled under Article 518, covering places of assembly. Exam rooms in an animal hospital are considered places of assembly because they are areas where people, including staff and pet owners, congregate. Article 518 dictates requirements for illumination levels, emergency lighting, and receptacle spacing. The goal is to provide a safe and functional environment for both the animals and the people using the space. For instance, adequate lighting is essential for conducting examinations and performing medical procedures. Emergency lighting ensures that occupants can safely evacuate the area in the event of a power outage. Now let's consider the unique challenge of installing an MRI machine. These machines have very specific electrical requirements due to their high power consumption and sensitivity to electrical interference. The installation must comply with manufacturer specifications and industry best practices in addition to the NEC requirements. This often involves installing dedicated circuits, isolation transformers, and specialized grounding systems to minimize electrical noise and ensure the MRI machine operates reliably. Coordination with the MRI vendor is essential to ensure that the electrical system meets their specific requirements. Grounding and bonding play a critical role in ensuring electrical safety and minimizing the risk of electrical shock. The NEC specifies detailed requirements for grounding and bonding electrical systems, including the size and type of grounding conductors, the methods for connecting grounding electrodes, and the bonding of metal enclosures and equipment. Proper grounding and bonding provide a lower impedance path for fault current to flow back to the source, tripping a circuit breaker or fuse and energizing the circuit. This helps to prevent electrical shock hazards and minimize the risk of equipment damage. Local amendments to the NEC can vary significantly from one jurisdiction to another. These amendments may address specific local conditions or concerns, such as seismic activity, extreme weather, or unique building characteristics. It's essential to research and comply with all applicable local amendments in addition to the NEC requirements. Failure to comply with local amendments can result in fines, project delays, or even legal action. Staying up to date on the latest version of the NEC and any applicable local amendments is crucial for ensuring electrical safety and code compliance. The NEC is updated every 3 years, and each edition includes revisions and updates based on new technologies, industry best practices, and field experience. Subscribing to industry publications, attending training courses, and participating in professional organizations can help you stay informed about the latest changes and developments in the electrical industry. A qualified electrical contractor brings expertise, experience, and specialized knowledge to the project. They can help you navigate the complex requirements of the NEC, ensure that the electrical system is installed safely and correctly, and provide ongoing maintenance and support. Selecting a contractor with experience in healthcare facilities and MRI installations is essential for ensuring a successful project. When dealing with medical equipment, isolation power systems may be required. Isolation power systems are designed to protect patients and medical personnel from electrical shock hazards in critical care areas. These systems use an isolation transformer to isolate the electrical system from ground, reducing the risk of leakage current and electrical shock. Isolation power systems are typically required in operating rooms, intensive care units, and other areas where patients are at high risk of electrical shock. The NEC specifies detailed requirements for the installation and testing of isolation power systems. Surge protection is essential for protecting sensitive electronic equipment from voltage spikes and surges. These surges can be caused by lightning strikes, power grid switching, or other electrical disturbances. Surge protective devices, or SPDs, are designed to divert excess voltage away from sensitive equipment, preventing damage and ensuring reliable operation. The NEC requires surge protection for certain types of equipment and in certain locations, such as healthcare facilities and critical infrastructure. Regular inspections and maintenance are essential for ensuring the continued safe and reliable operation of the electrical system. The NEC requires periodic inspections and testing of electrical systems to identify potential hazards and ensure that the system is operating within safe parameters. Regular maintenance, such as tightening connections, replacing worn components, and testing protective devices, can help to prevent electrical failures and extend the life of the electrical system. Documenting the electrical system with accurate and up-to-date drawings and specifications is essential for future maintenance and troubleshooting. These documents should include information about the location of electrical equipment, the wiring methods used, the circuit breaker schedule, and any special requirements or considerations. Maintaining accurate documentation can help to ensure that future work on the electrical system is performed safely and correctly. Always prioritize safety when working with electrical systems. Electrical work can be dangerous, and it's essential to follow safe work practices to prevent electrical shock, arc flash, and other hazards. This includes wearing appropriate personal protective equipment, such as gloves, safety glasses, and arc-rated clothing, and energizing circuits before working on them. It's also important to be aware of the potential hazards associated with working near energized equipment and to take steps to minimize the risk of electrical accidents. Consider wire and conduit fill. The NEC specifies the maximum number of conductors allowed in a conduit or raceway. This is known as the conduit fill requirement. Exceeding the conduit fill limit can cause overheating, damage to the conductors, and increase the risk of electrical failure. It's essential to calculate the conduit fill before installing conductors to ensure that the installation complies with the NEC requirements. Similarly, the NEC specifies the minimum bending radius for conductors and cables. Bending conductors too sharply can damage the insulation and reduce the current carrying capacity. It's essential to follow the manufacturer's recommendations for bending radius and to use appropriate bending tools to avoid damaging the conductors. Also consider proper labeling and identification. The NEC requires that all electrical equipment be properly labeled and identified. This includes labeling circuit breakers, switches, receptacles, and other devices to indicate their function and voltage rating. Proper labeling and identification can help to prevent confusion and errors during maintenance and troubleshooting. The labeling must be durable and legible and must be installed in a conspicuous location. Next, arc flash hazard analysis is important. An arc flash is a dangerous electrical explosion that can occur when there is a fault in an electrical system. Arc flashes can cause severe burns, blindness, and even death. The NEC requires that employers perform an arc flash hazard analysis to determine the potential hazards associated with working on electrical equipment. The analysis must identify the arc flash boundary, the incident energy, and the required personal protective equipment. Training requirements must be met. The NEC requires that all electrical workers receive adequate training in electrical safety and safe work practices. The training must cover topics such as hazard recognition, lockout-tagout procedures, personal protective equipment, and emergency response. Employers are responsible for ensuring that their employees receive the necessary training and that they are competent to perform their assigned tasks safely. Lastly, consider emergency shutdown procedures. It is important to establish emergency shutdown procedures for electrical equipment in case of a fire, electrical shock, or other emergency. These procedures should include instructions for de-energizing equipment, evacuating the area, and contacting emergency services. The procedures should be posted in a conspicuous location and all employees should be trained on how to implement them.